to the Balverzin booth here at Electronica. I'm delighted to be joined by two very significant people from the solder industry. We've got Tetsuro Nishimuro here from Nihon. Nice to see you, Tetsuro.
Yeah, thank you very much.
Okay. And to my right, we have Josef Jost from Balverzin.
Welcome to Electronica.
There we go. So we have two very significant announcements here this week. And the first, I'm going to turn to Tetsuro-san here about some discoveries you've made with the copper content in solder baths. Typically, the copper content, you keep adding it and it goes out of spec. But you have brought out a new alloy that really helps to combat that issue.
Right. In the web solder bath, we have to maintain the as same as possible from the beginning. So that's why additioning alloy must be less copper content. So that's why we found the additioning nickel and germanium onto the solder. It's become cross section. So the cross section, it's we found very, very stable. So that's why finally we found solder composition, which nickel does help.
So this alloy that you're adding to the bath, this is a specific alloy that you have developed and patented from Nihon Superior, correct?
Yeah, because we did a lot of experimental cross section experimental. So why additioning nickel, you cannot see any crack in the we call IMC, intermediate compound, very, very stable and very beautiful. Right. So that's why finally we found the new alloy, new composition alloy.
Right.
Yes.
Well, I mean, that's a very significant announcement. I mean, Joseph, how big an issue is that here in Europe?
Actually, yes, the solder bath management is a day-to-day business for the workers on the line. And, you know, with our analyzing system, we offer a lot of service to maintain the solder parts, the solder baths. Either it is a Hazel line or a wave solder pot or a selective solder pot. You have different segregations in the alloy. So, yeah, the maintenance of a solder bath is the most important part to have a stable production.
Right.
So it's very important for the customers to have it.
Right.
So Gladful, we know how to manage.
Excellent. So I mean, but there aren't really any systems, are there, for monitoring the composition of the solder bath on a regular basis?
There are regulations, but we talk to customers because it's a customized process. So actually, they have a product variation where the solder pot or the solder bath is varying in copper, nickel, germanium content, and then we tell them what to add to really maintain the pot. No, right. Whether they have to add tin nickel or tin germanium, or maybe tin nickel germanium in a higher percentage. So yeah, actually, this is a day-to-day bath management, solder bath management, and I think customers are very happy on our service, right, which is actually provided from the help of Nihon Superior, no?
Superior, yeah. That's interesting. I mean, because obviously people who are just putting more solder in are also putting in more copper, and eventually the process goes out of control.
Well, and also I have to tell, additional nickel is very, very stable. So that's why the solder connection reliability is perfect. Now, without nickel and germanium, it does break.
Right.
Yeah, under the severe condition.
Right.
But with additioning nickel, it does help.
Yeah. Right. So while you were doing this work, Tetsuro, you also made another very significant discovery. Can you tell us a bit about that? This forms your second patent.
Yeah, because as I said, additional nickel, it does react with copper and nickel dissolve each other, but together with the tin, well, tin copper has a intermetallic, and which is quite brittle. It doesn't stay. But additional nickel, it doesn't happen. Very, very flexible, and it doesn't make any breaks.
Right.
So that's why the composition is very important in the soldering connection.
Right. So the nickel brings in some sort of elasticity or some makes it not quite so.
Actually, it's even more important because with all the different surfaces you have on a printed circuit board, you have nickel gold, you have tinning, you have silver, you have hot air leveling surfaces. If you have a stabilized alloy, you could do a stabilized solder joint. And this is where we think that the patent is really helpful, because it also impresses to the people who use this that there is an alloy which helps them for a stabilized processing.
Right.
The solder joint patent really gives them the opportunity to make quality, long-lasting solder joints without cracks in the future.
Right. Reliability. So, okay, so the SM100C patent, as we said, expires at the end of March, but the solder joint composition is still covered by these other patents. Can you tell us exactly what composition is covered?
Oh, it's a tin copper nickel and germanium alloy.
Okay, so tin copper nickel with germanium alloy is still covered under these other two patents that you've announced today.
Exactly, yes.
Well, that's very significant news, gentlemen. I mean, do you see there's going to be much pushback here in Europe?
Actually, I think that it's going to stabilize the market a little bit with all these different alloys running around, which additioning this, additioning that should help, and this and this and this. But the qualification which is done in the car and automotive industry definitely shows that S1C is one of the most popular alloys in our future, and especially to electromobility, electro cars. It really helps.
Really helps, yeah.
Because I like silver, it's costly, and I like to sell it.
Right.
But with minus 40 degrees C, it's really difficult to charge a battery.
That's right.
Thank you.
No, well, you're absolutely right, and I mean they're expanding these temperature ranges all the time for the automotive industry. You know, minus 40 plus 150 is quite a bit. So that's two very significant announcements. Of course, there'll be more detailed information in the press over the next few months, I'm sure. But for now, this is Trevor Galbraith saying thank you to Tetsuro Nishimura, and of course to Josef Jost
Thank you
from
very much,
Balvazin.
Trevor.
And thank you for joining us.
Thank you.